Okay, welcome back to yet another tutorial video of the EC June 2022 Maths Paper 1 Revision Series. We are now going to do question 5 of this paper. And as you can see for yourself, this is another question on functions. By the way, if you are finding these videos helpful, please make sure that you click the like button, as this helps the video to reach many more people who may also find it helpful. And don't forget to subscribe and click on the notification icon so that you don't miss out on any video that is uploaded on the channel. Anyway, I hope you have your pen and a piece of paper as we are about to get started. So here we've got the graphs of f of x is equal to 2 into x plus 1 squared minus 8, and g of x equals to 1 over 2 all to the power of x, and we are told that these are represented in the sketch below. And we are also told that P and Q are the x-intercepts of F, as we can see in the diagram, and R is the turning point of F, as also indicated in the diagram. A with coordinates -2 and 4 is a point on the graph of G, as we can also see on the sketch. And of course, the graph of f is a quadratic function, as we can see from the sketch, but besides that, we can also see from the equation, because this equation, f of x is equal to 2 into x plus 1 squared minus 8, is a quadratic equation, but in the form y is equal to a into x plus p squared plus q, as this is an alternative way on which an equation of a parabola or a quadratic function can be presented. And of course, this can be obtained from the standard form of the quadratic equation. Y is equal to ax squared plus bx plus c by completing the square. So presenting a quadratic function or equation in this format has got its advantages. For an example, in this format, the turning point of the quadratic function is simply given by negative p and q. So we take the value of p here and change its sign for the x value, and for the y value we just simply take the value of q as it is. And so this is one of the primary advantages of this format. Now, g of x is of course an exponential function. As we can see, it's in the format y is equal to b to the power of x. And as we can see, the value of b in g of x is greater than 0 but less than 1. And from the properties of exponential functions, we know that this basically means that g is a decreasing exponential function. Okay, so now let's move on to the questions. So 5.1 says, write down the equation of the axis of symmetry of F. So here, you must remember that a quadratic function has got an axis of symmetry. And this is simply a vertical line which cuts the quadratic function into two mirror images. And so this line is always a line which passes through the turning point. And since it is a vertical line and thus passes through the x-axis, the equation of this line is given by the x value of the turning point. And so you must note that the instruction here is write down, and this is only for 1 mark because since they have given us the equation of f in this format, we can immediately see that the turning point of f, that is the coordinates of r, are going to be given by -1, because for f the value of p is +1. Therefore the x value of the turning point will be -1, and the value of q is -8. So these are the coordinates of the turning point r, and the x value of the turning point gives us the equation for the axis of symmetry. So x is equal to -1. And now the second question here is asking us to write down the coordinates of r, which is the turning point of f. And obviously we've already answered that the coordinates of r are just simply -1 and -8. So that's it for 5.1 and 5.2. So 5.3 says determine the coordinates of P and Q. And again, this is also very simple because P and Q, as we can see and as it was clarified in the statement, these are the x-intercepts of F. So in order to find the coordinates of P and Q, we just simply need to let y equal to 0. And now this is the equation of the function. So if we let y equal to 0, it basically means that we make f of x here equal to 0. So this is the equation we get, and now we can just simply solve for the x values. So since the equation of this parabola is in this format, we can just simply transpose the 8 to the left hand side. So it will be +8. And now we'll have equal to 2 into x plus 1 squared. After this, what we can do is we can divide by the 2 on both sides of the equation. So we are going to have 4 is equal to x plus 1 squared. And now after this, all that we can do is we can take the square root on both sides of the equation. So if we do that, we are going to have that plus -4 is equal to x plus 1. And therefore, we are going to have x plus 1 is equal to 4, or x plus 1 is equal to -4. And therefore, this means that the values of x here are x is equal to 4 minus 1, which is 3, or x is equal to -4 minus 1, which is equal to -5. So these are the values of x for the x-intercepts, and therefore we can conclude that the coordinates for P are going to be, so note that the two values of x that we have obtained are positive and negative. We can see that P is the intercept that has a negative value of x, while Q has a positive value of x. So the coordinates of P here are going to be the one that have the negative value of x. And of course, in the x-intercept, the y value is 0. And for Q, it will therefore be 3 and 0. And so that's the solution for 5.3. And so now in 5.4, we are asked to determine the equation of the inverse of g in the form y is equal to. So again, this is the equation of g. So in 5.4, we want the inverse of g, and so to find an inverse of g, we need to interchange x and y and then make y the subject of the formula. So first of all, we can write this equation of g as y is equal to 1 over 2 to the power of x. And now, as I was saying, we need to interchange x and y. So if we do that, we are going to get x is equal to 1 over 2, all of that to the power of y. And thereafter, we need to make y the subject of the formula. And the only way we can do that for an exponential function is by using logarithms. So 1 over 2 is the base here, and y is the exponent. So we want to make y the subject of the formula. So there it is. And then we will have log with the base of 1 over 2, because 1 over 2 is the base here. So 1 over 2 is going to be the base, and then inside the log we just write x. So this would be the inverse of g. And now 5.5 is asking us to sketch the graph of the inverse of g, and we must clearly indicate the intercept with the axis and at least one other point on the inverse of g. So for convenience, I will just demonstrate this on the same set of axes as in the question. So here's a trick that you can use to do this. So the fundamental thing about the inverse of a function is that you interchange x and y. So this means that in the coordinates that make that particular function, you change the values of x to be the values of y in the inverse, and the values of y will change to become the values of x in the inverse. So for an example, we've got point A here with coordinates -2 and 4. In the inverse, this coordinate is going to change into 4 and -2. So in our inverse, we are going to have this coordinate. The x value is +4, so maybe it's about here, while the y value is -2. So maybe we can show it here. We are just sketching. So this is a point that we certainly should have in our inverse function. And in addition to that, we also have another point, this one. So the coordinates of this point are actually 0, as you can see, because this is a y-intercept. So the x value is 0 and the y value is 1. And we can see this from the equation of g. This is the equation of g. So if we make x equal to 0, we are going to have y is equal to 1 over 2 to the power of 0. And of course, that is equal to 1. And so now, likewise, this point in the inverse is going to change into 1 and 0 because we interchange x and y. So in our inverse, the intercept that we have is going to be the x-intercept at 1 and 0. So maybe we can show it here. Okay. And in addition, we also know that another property of an exponential function like this one is that it has a horizontal asymptote along the x-axis, indicated by the red dotted line that I'm showing. Okay, so what does this mean? This also means that if in the original function this horizontal asymptote is this line, y is equal to 0. It means that in the inverse, this horizontal asymptote or y asymptote is going to change into an x asymptote or a vertical asymptote, and we can show it like this by this vertical line. Its value is still 0, but this time it's no longer y is equal to 0, its x is equal to 0. And so with all of this information, we can now sketch the inverse of g. But now for simplicity, I am going to remove some of these points. And so as we can see, for our inverse, we've already have got 2 points. So we can draw a curve, and so we can draw a curve both of these points. Okay, and so now maybe let me bring this point down a little bit, and now we can just simply draw a curve that passes through these points, and it can go closer to the asymptote but should never meet it. So this is how the inverse of g is going to look like. And remember that this coordinates here is what was previously called a point A. So the coordinates, as we had discussed, are now 4 and -2. And this is also another important point that you should show, which is the point 1 and 0, as we had discussed. That's how you can sketch the graph of the inverse of g. So 5.6 says for which values of x is in 5.6.1 g inverse of x greater or equal to -2. Okay, so for which values of x does this apply? Where g inverse of x is greater or equal to -2. So we can simply answer this question from our graph, which is why I have shown our little sketch here for the inverse of g again. So what does this mean? So we are just looking here for values of x whereby g inverse of x is greater or equal to -2. So we can say that from our graph, g inverse of x is equal to -2. That is, the y value is -2 when x is 4. That is at this point. When the value of x is +4, g inverse is -2, right? So we already know that we need to check now where is g inverse of x greater than -2, right? So, and so g inverse of x is going to be greater than -2 starting from here and so on. Because for all these values of g inverse of x, as you can see, all of these values are above -2, so they are greater than -2. Therefore, to answer 5.6.1, we can just say that x is an element, open bracket, of 0, because remember that 0 here is an asymptote. So the values of x for g inverse are never going to equal or be less than 0. And now, so starting from values that are greater than 0 up to 4 is our solution. And we use a square bracket here because there is the or equal to sign. So that's how you can do 5.6.1. And now for 5.6.2, we want to find x, f of x less than 0. Now this one, I would suggest that we do it by algebra. And here's what we need to do. We need to take f of x and substitute it in here. So f of x has got this equation 2 into x plus 1 squared minus 8. So we can just simply solve for x in this inequality. So let's start by multiplying by this x into the bracket. So this is going to give us 2x into x plus 1 squared minus 8x is less than 0. Okay, and thereafter perhaps we can expand this bracket as well. So if we do that, we'll have x squared and then x multiplied by 1 multiplied by 2, which is 2x, and then 1 squared, which is 1, minus 8x is less than 0. And now the next thing is to multiply by 2x into the bracket. So this gives us 2x cubed plus 4x squared plus 2x, and then we carry down negative 8. All of that is less than 0. And now from here, we can add up our like terms. So we've got 2x cubed plus 4x squared, and then we've got positive 2x minus 8x, which gives us negative 6x less than 0. And now from here, we can simplify this further by taking out a common factor here, because we can see that we've got x in all of these terms, and we've got 2, 4, 6. So we can take out 2x as a common factor. And if we do that, we are going to be left with x squared plus 2x minus 3 less than 0. And therefore, we can now find the critical values. So the first one, we'll get it from 2x is equal to 0, which means that x is equal to 0. And we're also gonna get another set of critical values from the quadratic equation. So we also set that to 0. And this here, we can just factorize it. We can solve it by factorization. So we've got x, and here we've got 3. So the factors of 3 are 3 and 1. This 3 is negative, meaning that the signs that will go into each bracket are not going to be the same. And then the middle term is positive, which means that the bigger number here must be positive. So 1 should be negative. Therefore, we are going to have x plus 3 is equal to 0, or x minus 1 is equal to 0. So we've got x is equal to negative 3, or x is equal to positive 1. And so these are the critical values. And thereafter, we can just use the number line method. The number line method, so we make a number line and we indicate our critical points. So we've got negative 3, which is the smallest number, and then we've got 0, and lastly we have got positive 1. So these are critical values. So these are the values where our equation is equal to 0. And now what we need to do is we need to plug in values that are going to fall within each of these intervals, and then determine the sign of our equation. And this is what I mean. So for the first interval, we can substitute for an example -5, because -5 is within this range. So if we do that, we will have 2 into -5, and all of that into -5 squared plus 2 times -5 minus 3. So let's see what's the sign of the value we get. So we get -120. So the important thing is that it is negative. So we write a negative sign there. And then we move on to the second interval. So we need to take a value that is between -3 and 0 and sub it into the equation. So I guess for this one, maybe we can take -1. So we'll have 2 into -1, and then we'll have -1 squared plus 2 into -1 minus 3. Oops. And from that we get a positive value. So here we write a positive. And now we need to take a value that is between 0 and 1. So maybe we can use a half. So we'll have 2 multiplied by half. And then here we have a half squared plus 2 times the half minus 3. So what do we get? We get a negative value, and therefore we are going to write a negative here. And lastly, we need to take a value that is greater than 1. So we can just take 2. 2 is greater than 1, and then we substitute 2 throughout. And so here we get 20, a positive value. So here we will write +1. So in our inequality here, we are looking for values of x where the expression is less than 0. So we are interested in the negative values. So we see that this expression is negative for x is an element, negative infinity to -3. And in addition, also for values from 0 to +1. So that's the solution for the last question. Simply like that.